Welcome back. Let's continue from where we left off in the previous video. We were looking at servers, ports, different protocols, and services that are provided with different servers. So today we're going to be looking at the Open System Interconnection Model. The OSI model is a framework that explains how data travels from one device to another across a network step by step. Think of it as passing a note through 7 stages before reaching your friend's phone. So when you transmit data from your computer or from your phone, and as it goes to the other computer and the other network or on the same network, we use cables, and the data is transmitted as ones and zeros, but we want to be able to break down the way this data is transmitted in a way that we can be able to understand. So it's like more like a classification for us to understand how this data goes through the stages so that it can reach the place where we're trying to send it. It can reach its destination, okay? One of the frameworks that we can use is the Open Systems Interconnection Model, the OSI model. When you look at the application layer, here we usually think of the type of application that you're using. Is it WhatsApp? Is it Google Chrome? Is it Facebook? Is it Instagram? And what service are you trying to access? Is it a web server? Is it a file server? Is it HTTP that I'm using? Is that the protocol that I'm using to access whatever I'm trying to access? Or is it a file server? Is it whatever service that you're trying to access? Is it DNS? Is it SMTP? Is it like email? So am I using SMTP to access an email? That's in the application layer. And when we have data in this layer, it's called what? It's called data. When we go down to layer 6, that's the presentation layer. Over here, we need to think about data formats. You know, the way we save files, a Word document will be saved as .docs. An Excel file will be saved as .xls. The way things are saved, it's usually called file extensions. If you want to see the file extension, if you're using Windows, just come to your folder, go to View up here, and then go to Show, and then Show File Extensions. Just check Show File Extensions, and you'll be able to see this kind of stuff. So you'll be see like this is a .mp4. I know that's a video or an audio. It could be an audio too. .pdf. I know that this is a PDF file if I'm opening it. .jpeg. That's a picture. So presentation looks at that. Presentation looks at the data formats. Yeah, so it looks at the data formats. What data format is this file in? Okay, is it an email file? You know, something like that. And when data is up here, it's still called data. And then layer 5, this is the session layer. This one maintains communication sessions between devices, making sure that both sides of the connection stay in sync. It also handles things such as login sessions, timeouts, and recovery of connection drops. So, you know, the cookies, session cookies, when you hear about session cookies, when you usually save your password to your browser and stuff like that, and then you close out of your browser, and then when you open it again, you don't have to log back in because the session has been saved and now it just connects directly. So that's the session layer that is responsible for all that, maintaining that connection, making sure that the conversation does not drop. And when data is still on this layer, it's called data. We go to layer 4. Over here, we are thinking of the transport. So here we're breaking data into chunks. We are using protocols such as TCP. TCP is Transmission Control Protocol, and UDP, which is User Datagram Protocol. On this layer, we are thinking something like Postal Service, DHL, UPS, FedEx, Uber. I'm just using examples. So Uber or Bolt. Or I like giving this example. We use a public means of transport called matatus. And when you think of matatus, where are you trying to go? So the different matatus have different route numbers, and those route numbers tell you wherever you're trying to go. You know, something like I think it's 111 goes to Gong Road, number 15 goes to Langata. The delivery service, the transport layer, it's in the name, the transport. So the delivery service that we are using. Something like TCP is more reliable, but it's a bit slow. And then UDP is for fast delivery, but it's unreliable. We usually use different transport protocols for different services. It's a matter of what service you're trying to use. An example, let's say you're trying to make a phone call. You don't want it to be slow. When you're talking to someone, you want to hear them almost immediately, right? So the protocol that is used on a phone call is UDP because it's faster. But TCP is a bit slow but more reliable. For example, let's say when you're doing banking, when you're paying, when you're paying, you need something like TCP to be more reliable because it checks. If it's sending messages, it would check, did you receive that segment? Did you receive it? If you haven't received it, let me send it again. But with UDP, it just keeps on dishing out. It just keeps on sending and sending and sending and sending. But anyway, we'll look more into TCP and UDP. When data is on this layer, it's broken down into things called segments. So when you think transport layer, you're thinking of segments. Layer 3, this is the network layer. When we think of this layer, we're thinking of the router. So routing protocols. The more you go into networking, you learn that there are routing protocols, something like BGP or SPF, all those protocols to be able to route traffic from one network to the next so that you are able to send traffic between routers so that they can go to different networks. And also another thing that lives here that we have looked at already is IP addresses. An IP address showing the different networks. So the router needs to know the IP address for this network and then know the IP address for the other network so that it can route traffic between those two IP addresses. When traffic is at layer 3, it's broken down into packets. When you think of layer 2 now, layer 2, we're thinking of switch and the way it forwards traffic. Switch uses MAC address. So in layer 2, we're thinking of also the MAC address. And that's how the switch would forward traffic. So it would look at the source MAC address. Where is this frame? Because when data is here, when data is on this layer, it's called frames. So where is this frame coming from? What is the source MAC address of the frame? And then what is the destination MAC address of the frame? So in layer 2, we're thinking of the MAC address and how the switch forwards traffic using MAC address. And then in layer 1, this is the physical layer. Over here, we're thinking of how are we actually transmitting this data from one computer to the next one. So we could be using Ethernet cables. So we are sending data as electrical signals, yeah? So zeros and ones. We could be sending this data through a fiber optical cable. So as we're sending it through a fiber optical cable, then it goes as light. Or we could be sending this data using wireless. So probably maybe it's a Wi-Fi access point sending data to different devices, or we're using something like Starlink, Starlink satellites. So they're sending wireless radio signals. So what physical medium are we using to transport this data from one computer to another? That's layer 1. And when data is in here, it's called bits. We have a mnemonic that you could use to sort of memorize all these layers, and that is all people seem to need data processing. So application, presentation, session, transport, network, data link, and physical. I want to say this. When this data is moving all the way from up here, going down like this, because this is where the user is interacting, the application layer. This is you're interacting with your phone, with your WhatsApp, with your Google browser. This is where you are interacting with it, and then the data is formatted into like different formats, and then it goes down, and then there is a session that is established as it's transmitting over the network, and then we choose like whatever we're trying to send it with, like what vessel are we trying to send it on, is it TCP, is it UDP, and then like the IP addresses with the router, and then the MAC addresses with the switch, and then like the physical medium, wires or wireless or light, as it goes down, this data goes, it's like we're putting it in different envelopes. I'm going to classify all this as one. This first part, layer 7, layer 6, and layer 5, I'm going to classify them all as one layer for now, just sandwiching them. Because all of it, when data is there, it's called data. So this is like our envelope that has data. And then now when we go to the transport layer, we put it on a different envelope. And that envelope, so we decide to write either TCP or UDP. That's the vessel that we're putting it in to transmit it on, And then when it comes down to the network layer, we put the IP addresses. So the envelope now has source IP address and destination IP address so that the router can be able to route the traffic. And then as it goes down, we are now thinking of the MAC address. We're no longer looking at the IP address because the switch cannot even see this IP address. The switch does not see whatever is up on that side. The more we go down, the layers down only see what they need to see, okay? The switch only sees the MAC address, source MAC address and destination MAC address. And then it goes down into the wires, and then it's just now ones and zeros, and we're sending it as bits over the wire, okay? So as we go down, as we put it in the envelope, that is called encapsulation. Encapsulation. And as it reaches the other computer on the other side, so, as we are sending it from that computer, it goes over the wire and then reaches the other computer on the other side, it starts going back up. So it starts going up from the raw data into the switch and then the router, and until it gets to the user on the application layer, and now the user can be able to see the information that has been sent over the wire. So as it goes back up, that's decapsulation. We've looked at the OSI model, but this is a bit older. Whatever we use these days is the TCP IP model. It's literally the same thing, but just layer 7, 6, and 5 have been compressed into the application layer, just as we did, because we said, like, when data exists over here, all of it is just data. So we just decide to sandwich all of it together. And then now we can start breaking it down as we go to the transport. Over here, we're thinking of TCP, UDP. On the network layer, we're thinking of the IP address. So the source IP, destination IP, and then routing protocol. When we go down, this one is usually still divided. It's a matter of what you're looking at. If you're going through this via Cisco 2 and 1, they're still data link and physical layers, but other people just put them together, call it the network interface. Over here, we will be thinking of MAC address, the switch, and also bits, data being changed into ones and zeros so that it can be transmitted over the cables. I hope you found that information helpful, and I'm looking forward to seeing you in the next class.